You have worked so hard to build that house you've been dreaming of, but you don't have the required amount of money to make it happen. Then you reach out to two loan services. Unfortunately, none of them accepted your request. And the first one sent you an email telling that your request cannot be approved, and that's it. No explanation. The second one does not only tells you why your request has not been approved, but also provide all the details explaining why they have refused your request. Which one of these two services are you going to reach out next time? For me, it will be definitely the second one because all the insights they provided will help me make the relevant adjustments to increase my chance of being accepted next time. And the same principle applies to machine learning models. Decision makers will be willing to use and trust machine learning models that they can understand the decision making process. In this tutorial, I'm going to explain how you can implement and add that explainability layers to your machine learning models. If you're ready, let's get started. To illustrate the implementation of the explainability, we'll be using the diabetes dataset. This dataset contains information about patient which explain if a given patient has diabetes or does not have a diabetes. So we have these columns from pregnancy to age, and the outcome is the column that we're trying to predict. Let's start with the model training. We're not going to spend too much time on the model training since the main goal is to really understand how the explainability works. To do that, we're going to import the relevant libraries on train test splits used to create training and testing data. And we are going to train a random classifier, random forest classifier, and also import some functions that will be used to generate the metrics of the model. Now we start by separating the feature and the target variables. We get all the features data by dropping the outcome and y is the outcome column. Then we have those two information here. And now we create the training and testing data where 70% of the data is used for training and the remaining 30% is used for testing. And then now we build the model using the random forest classifier, providing some hyperparameters here, the maximum number of feature, number of trees that we're going to use in this random forest, and we activate the bootstrapping. And we have the training of the model. After training the model, now we can make the prediction using the test data. And finally, we show the classification report, which is going to provide all the metrics of the model. So we have the precision recall F1 score. Now that we have trained the model, the goal now is to make predictions and understand the decision-making process of the model, right? So to do that, we're going to use LIME. LIME stands for Local Interpretable Model Explanation. This local interpretable means that the model is going to make an explanation of its prediction based on that single observation. And the first step is to fit the explainer. Before fitting the explainer, we install the LIME library with pip3 install LIME. I have already installed LIME, so I'm not going to run it again. And now from LIME, we're going to import the LIME tabular explainer. And after the tabular explainer, we have the classes that we are interested in. We have has diabetes and no diabetes. Has diabetes is for class 1 and no diabetes is for class 0. This list has been used to make it more readable. And now we get the features name in the attribute features name. And finally, we fit the explainer. We create an instance of the explainer, which is going to take information about the training values. After the training, we have the features name and class names, and we activate the mode, which is classification. And at the end of this process, we have an instance of the explainer that we can use the next step to explain the model's prediction. So this starts with an explanation. Let's say that we're going to take the ninth observation in the test data and we use the random forest classifier by taking the probabilities of the two main possibilities, has diabetes and no diabetes. After we have that, now we can show the result of the model's explanation in a tabular format. And here is the results of the model's prediction. On the left, we have the model's prediction. So we have 68% of the models telling that this patient has diabetes, and the remaining probability is 0.32, no diabetes. The general prediction of this model is that the patient has diabetes. And on this, in the middle, we have the kind of logical explanation of the model. The model says that this patient has diabetes because the glucose level is higher than 99. Thickness is less or equal to 0. And also the blood pressure is higher than 70. And insulin is 0. These are the reasons why the model says that this specific patient has diabetes. And the reason why it might not be a patient with diabetes is because the pregnancy number is higher than 6 and the patient is like in the age range of 29 and 40 and the BMI is between 27.6 and 32.4 and diabetes pedigree is higher than 0.39. So here are the logical explanation of the model's prediction. And finally, on the right, we have a table with two main columns. We have the feature column and the values of those features for this specific patient. And here the model said the glucose level of the patient is higher than 99. And by looking at the table, we can see that the glucose value is 104, right? Which is indeed higher than 99. And the skin thickness is equal to 0, which is that value. The blood pressure is higher than 70 and blood pressure is 72, right? So in blue are the values for the has diabetes parts, and in orange we have no diabetes parts. This is how you can explain the model's prediction using Lime. If you like this tutorial, give it a thumbs up and also let me know in the comments if there are some other topic that you want me to cover in my next video. Thank you for watching and see you next time. Bye bye.